Okay, welcome back. This is our module 2 for week number 5, and today we are going to continue talking about the instruction set architecture. So we stopped at the control unit, and we said that the CPU consists of two things, which are the uh, data path and the control unit. The data path contains the ALU and the registers, and the second part is the control unit. So our control unit, we are going to talk about a hardwired control unit, means it's an actual circuit. So basically what we have to do is to create a control unit, which is this part in blue. Okay, we want to create this control unit that is going to support our simple data path over here. So for convenience over here, we show the data memory and we show the instruction memory as seen over here. Now you can see a few things different. You can see the zero fill, which fills the operand. When you have an operand, let's say we said R1 plus 2, put the result into R3. So 2 is basically 3 bits, which is 0, 1, 0. We need to zero fill it in order to make it 8 bits. So we zero fill 5 bits. So this is now total 8 bits. So this is the job of the zero fill. We see that the memory address is going from bus A. The memory A data is going through bus B, and you can see that the data out is going over here to the memory. The data N, which is connected to mux D, is connected through this line over here. Now let's focus a little bit on this part over here. Now this part over here contains the actual things that we are going to talk about today. So basically, this is our instruction memory, and the instruction memory over here contains our instruction, which is controlled by the program counter. The usual operation of a program counter is basically PC, put in it PC plus 1, unless we have a branch instruction. As you can see here, we have one line going from bus A into the program counter, and this is basically to associate this instruction, which is the jump instruction, where RSA is put into the program counter. The contents of RSA will be used to address as a jump instruction. Now what we want to design is basically this decoder. This decoder will take the outputs from this memory, and it will give us BC, JB, and PL, which are used for the branch control, along with VC and Z. These are VC and Z, but for convenience, we connect them like this. Okay. Then you have MW, which is the memory over here. We have RW, which is for the register file. We have MD for mux D. We have function select for the function unit. We have MB for bus B, AA for bus A, BA for mux B, MB for mux B, BA and AA for the buses, and finally DA for the destination address. We need to find all these instructions from what we are going to get over here, which is 16 bits. So if you do a simple calculations, this is more than 16 bits. That is why it is called a decoder. That's why it's called a decoder. So the control unit, the data has been attached to the address out and output for the data lines in the data path. MU is the input for the memory, which is help us to write to the memory. It's also to show the signal over here. The zero fill, we talked about it, and we talked about the extent. This is the symbol of extent, the instruction register from 6 to 8 and 0 to 2. The branches which we are going to associate are branch on 0, branch on negative, and jump instruction. This is basically unconditional. These are conditional jumps. Okay, these are conditional jumps. The difference also is branch is for short distance. Jump is basically to any address. Okay, we jump to any address. So in addition to the above, the program counter should be able to do PC plus 1. So in order to do all of that, we need the PL jump / branch, and then we have the branch control. Okay, branch control. So if PL is equal to 0, then we are going to count up. يعني if PL is equal to 0, PC plus 1. If PL is equal to 1, this means we need to check, are we going to jump or we are going to branch? If it is equal to 1, then we are going to jump. If it is equal to 0, then we are going to branch. Now, if it's equal to 0, we have two options for branch, which are branch on negative and branch on 0. This one is for negative and this one is for 0. So it's quite, it looks complicated, but if you think about it, for PL, if it's 0, we count up. If it is 1, we are going to do some jump or branch. Now, if it is 1 with jump is equal to 1, we jump. If it is 1 with jump and branch equal to 0, we are going to branch. And we have two options to branch, which are 1 and 0. So to do all of that, we need to create this circuit. Okay, we want to create, this is the decoder circuit. So in order to create this decoder circuit, we need to go through all of these instructions. So you can see that the input instruction is 16-bit. The output controls are these signals, which I talked about earlier. So this leaves us with a bit of a complex circuit. Okay, so if you look over here, these are the operations that we are going to talk about. So function unit operations using registers. We are going to have the instruction bits, all of these are zeros, and this one is a don't care, and JBC and BC are don't cares. And PL, MW are equal to zeros, RW is equal to 1, MD and MB are equal to zeros. These are the types of instructions. In memory read instructions, we are going to read from the memory. The only difference is MD is equal to 1. Memory write instructions, MW should be equal to 1, and we are not going to read. Function unit operations using registers and constants, the difference is MB is equal to 1. Now, conditional branching with 0, PL, first of all, PL will equal to 1. Okay, notice here it's all don't cares. You never, ever, never, ever put these as don't cares. These, if you don't if you don't use them, put them equal to 0. Don't put the memory write or memory read or register write or register read as a don't care. So these, now it's jump and branch, all of these are equal to 0. This one is for jump, this one is from branch, this one is from branch on 0, and this one is from branch on negative, like we talked earlier. So combining all of this together, we are going to end up with this circuit. This is basically the circuit that will do the decoding. So this is 16-bit and your output is 20 bits. So if you go forward, we are going to see some examples on the instructions. This is the load immediate instructions, load instruction, store instruction, shift left, not branch on 0, and there is an explanation for all of these as examples over here. You can read them, and it's quite easy to understand. So basically this is all for week number 5. Hope to see you all soon, and if you have any questions you can ask through the online or the live discussions that we are going to conduct. Thank you for watching.